So today what I want to do is I want to make sure you know how to practice and use these laws to apply them to problems. So let's just review quickly. Boyle's law states that the pressure times the volume of a given system will be a constant. Or for a given system, P1V1 equals P2V2. And the video where Aubrey dives down 33 feet was our best example of that, but also the video where we remove air from a bell jar and you see the volume of air increasing in the graduated cylinder. That also proved Boyle's law nicely. Then we talked about Charles' law, and I put a series of syringes in different temperatures of water, and we proved that V over T is a constant. Now, we could also say V1 over T1 equals V2 over T2 for a given system. Then we also graphed each of these. If we were to graph a Boyle's law graph and make this pressure and this volume, it's an inverse relationship, so you get a nice curve like this. Whereas for Charles' law, this is a direct relationship. As one goes up, the other goes up. As one goes down, the other goes down. You would get a straight line. And we did that, and you saw that. And if you worked through those labs with me, then you should be quite comfortable by now with Boyle's and Charles' law. Now, I just want to give you a little bit of background on Jacques Charles. He was a French physicist, and he built his own hot air balloon. He inflated it with hydrogen, okay? So here's a hot air balloon. He inflated it with hydrogen. Now, if you've been in my lab, you know that hydrogen is very, very reactive. So you wouldn't want to have a balloon filled with hydrogen, and you wouldn't want to be in that balloon filled with hydrogen if there was some kind of friction going on up here, because if a spark hits that, it will explode. And that's what happened to the Hindenburg. There's some actual footage of the Hindenburg on YouTube that you can find. Very dramatic, very frightening, and we no longer fill our hot air balloons with hydrogen anymore. But Charles, what he did was, him and the Roberts brothers, they filled a balloon with hydrogen, and they actually sold tickets for people to come and watch them fly off in this thing. It was in 1783. So just to give you context, 1789 was the French Revolution. So it's 1783. It's December, so it's cold out. And they are in Paris. And he had a bunch of people come, he charged them, and that's how he funded his research, I guess. He had 400,000 spectators. That's pretty incredible. One of the spectators was actually a U.S. diplomat, and he was in the special guest crowd, and that was none other than our own Benjamin Franklin. So Benjamin Franklin was there, and he watched Jacques Charles fly off in his balloon. Now, the way the story goes, they ascended to a height of about 1,800 feet, which is 550 meters, and they landed. They flew for 2 hours and 5 minutes, so 2 hours and 5 minutes, and they flew 36 kilometers. Okay, the chasers on horseback, think about this. They couldn't just let those guys fly off. It's not like they could chase them in their cars below. No one had cars. So they actually had chasers on horseback chasing after them. And then because they had to be there when it was time for them to come down, because they had the ropes hanging down. Now, apparently, Jacques Charles was on such a high from this that when they did come down 36 kilometers away, the sun had apparently just set. He must have looked around and been like, dude, that was so good, I'm going again. He jumped back in, but the guy he was flying with did not, so now he was much lighter. And apparently he ascended rapidly to a height of 3,000, not feet, but meters. In fact, he ascended so high that he actually saw the sun again. The sun had set below the horizon from ground level, but he ascended 3,000 meters high, so he saw the sun again. And then apparently his ears started hurting, and he released gas and descended and landed about 3 kilometers away, and apparently that was his last flight. So his first one, I think, was everything he dreamed of. He got so excited. The way I look at it, he jumped back in his balloon, and I think after his ears started hurting and he scared himself, he came back down. But anyway, that's Jacques Charles. I just think it's pretty incredible that this was the science happening way back in 1783. Robert Boyle's experiments were done even earlier. Robert Boyle worked in 1662, so over 100 years earlier. And the crazy thing about Robert Boyle is there was no decent thermometer at the time. You know, you felt it. If it was hot, it was hot. It was cold, it was cold. So obviously he couldn't do work on temperature because they didn't have an accurate way to measure temperature, but he was able to do work combining and comparing pressure and volume. Next video, we'll talk about how to actually plug the numbers in and do some of the math and make it very easy. We call these plug and chug because they're very straightforward. Okay, I'll see you next video.